Welcome back to the Office of Science Outreach's Astronomy video series. Today we're going to talk about how you view during the day. Usually astronomers and observers talk about night sky viewing and the importance of seeing stars, satellites, and planets, but it's actually possible and easier to observe during the day. During the day we have the closest, most well-known star high in the sky. It's 93 million miles away from us, and we can observe it if we use safe observing techniques. To start, I want to stress that it is very important that you do not look at the sun directly. If you're going to look at the sun, you need to make sure that you use proper and safe observing techniques because we are using our eyes, and our eyes are extremely sensitive devices. If you were to look directly at the sun using your eye, you would experience something called solar retinopathy. In other words, you can experience damage to the back of your retina. And this damage occurs because the sun has so much ultraviolet radiation, or UV radiation, that it actually burns and damages the blood cells that make up the back of your eye. So in order to safely view the sun, we are going to avoid using direct eye and naked eye measurements. So do not look directly at the sun. Very important. If we wanted to observe the sun during the day, we have to use a handful of techniques. So I'm going to give you 3 techniques that are on the easier side. There are other techniques, but I'm not going to address them here. The first technique is to use proper filters. So the simplest method is to simply put a filter between your eye and the sun. So you can still observe using your eye, but it just needs to be protected. In order to do this, we generally use something called solar eclipse glasses, which makes it seem like you can only use them during solar eclipses, but that's not true at all. If you use them on an everyday basis and you continue to use them and view the sun, you might even be able to see things like solar or like sunspots or planetary transits. Another method related to this first method is by filtering telescopes and cameras. By filtering those devices, we're able to take pictures or images of the sun and view them later. So we aren't using direct viewing methods, but instead we're using imaging to view the sun at a later time. So if you were to use a telescope filter, there are a few different examples shown here. You would see different images. Some images show more activity, some show less activity, and they're all in different colors. And so what a filter does is it actually filters out the harmful colors and only shows you the ones that are safe to view, like blue, white, and yellow. Lastly, if you are patient enough, you are able to view the sun directly with your naked eye only during solar eclipses, and specifically during total solar eclipses at the point of totality, or the point where the sun is completely covered up by the moon. At this point, there's no direct harmful radiation coming from the sun to your eye. So you're able to avoid all sorts of harmful radiation entering your eye. And solar eclipses give us a really great viewing because you're able to see this thing called the solar corona, which is sort of this wispy extra stuff on the outside of the sun. So when you draw a picture of the sun and you draw rays attached to the sun, what you're actually drawing when you draw those rays is the corona. And for all of these devices and techniques, I'm going to post links in the bottom of the video, so go ahead and look there if you want to know where you can get solar filters. We're also going to post a DIY video for building your own solar filter for a telescope or a camera. And then I'll also post a link that shows you when the next eclipses are coming and where they'll be. Alright, so the next question is, what can we expect to see if we use all of these methods? To start, we'll start with the solar filter glasses. If you were to wear solar filter glasses, you should expect to see something like this. You'd see a giant yellow blob, that is the sun. You wouldn't see the rays coming off of it, but what you would possibly see are some sunspots or some cooler dark regions on the surface of the sun. They're dark because those spots are much colder than the rest of the sun, and so they don't emit as much radiation in that location. Another thing you could see with these filter glasses is a planetary transit. So these are much more difficult to see because against the sun the planets look so tiny, but this is an example of what it would look like if you were to watch Mercury transit across the sun. You'd see a small little black dot. moving very slowly across the surface of the planet or of the sun. What about telescope filters and camera filters? Well, this is what it would look like if you attached one to your telescope. You'd attach it to the end where the light is collected, and then you'd observe or take images from the other side. And as shown before, these images would look something like this if you were to use a standard telescope. Astronomers that study the sun, or solar astronomers, actually use lots of different filters and lots of different techniques for viewing the sun, and they can get a range of colors. So we can also track things from visible light, which is the yellow one on the top in the middle, or we can track super short wavelength, high energy ones, which is the very bottom corner blue one. And so by tracking all of these different wavelengths and colors, we're able to see the sun in different ways. So we can see what it looks like in visible light, and we can also see what it looks like in X-rays or gamma rays. Lastly, we can see the sun during eclipses. And it's very important that you only view the sun during a total solar eclipse. And so I'm going to show you what other eclipses look like and show you when you should directly view the sun versus when you need to keep those eclipse glasses on. So we have three types of solar eclipses. We have partial, total, and annular. Partial eclipses look something like this, where the moon never completely covers the sun, but just sort of does. So they kind of look like moon phases, but for the sun. And so when the moon covers up the sun, and we can still see part of the sun, that's called a partial eclipse. It's very important that we do not look directly at these because there is still some harmful radiation traveling to our eyes, and that can cause retinopathy, and we want to avoid that. The next type of eclipse is when you can safely view the sun, is during a total solar eclipse. And so during a total solar eclipse, what you'll see is a progression from the full sun to a completely blocked sun back to the full sun. So you'll see a slow progression of how much of the sun you can see. The only time it's safe to view the sun is when it is in its moment of totality, which is that center picture with all the wispies coming off of it in all the directions. That is the only time when it is safe for you to take your eclipse glasses off and directly view the sun. And lastly, we have this type of eclipse that is generally forgotten called an annular eclipse. And this is when the moon is angularly too small to cover the entire sun. So when the moon is super far away from us, it looks like it's tinier, which means that it doesn't cover as much of the sun as it does when it's closer. What this means is we can get what's called a ring of fire around the sun, or around the moon, which is just the sun's light still peeking through the edges. It is not safe to view these eclipses without your eclipse glasses on. The reason why is because you still have that direct radiation heading towards your eyes, which can cause short-term and long-term damage, and that's what we want to avoid. So I hope this helps you figure out how you're going to observe the sun during the day. Again, if you need solar eclipse glasses or you want to build your own filter, those links are in the bottom of this video. Please feel free to click on them and explore. And I cannot stress enough, please do not look directly at the sun. Thank you for visiting our video today, and happy sky hunting. We'll see you back here next week.